and in today's class we'll be creating and designing the one more component, that is horizontal stabilizer and vertical stabilizer. Commonly we'll call that as the empennage part of an airplane or empennage part of an aircraft. Okay, so we'll be creating that component. Okay, so here uh, we have the front view of our model of our project and the side view. Okay, and also the top view, right? Here we have the empennage section. This complete part is the empennage section. This one is our horizontal stabilizer and this one is our vertical stabilizer. Okay, so the clear dimension I mentioned here. Okay, in this slide, that is design a 3D horizontal stabilizer by using 2D parameters I have mentioned here. Okay, so the front view, top view and left side view of this horizontal stabilizer is given, and with respect to the views also have given the given data. Okay, like I have mentioned the data of a span of that horizontal stabilizer, chord, area, section. Okay, only one section. Okay, this complete horizontal stabilizer is not splitted. Okay, only one section is there, so easily we can see that one section completely, right, without any splitting. So that's why for that complete one section, span also I have mentioned, root chord, tip chord, sweep angle and dihedral angle. So we have to use all this data. Okay, which is not mentioned here. Okay, not mentioned here, but I have mentioned in this case clearly. Okay, so now we have to use this data and we have to complete our that horizontal stabilizer, and after this we'll jump to vertical stabilizer. Okay, design a 3D vertical stabilizer by using 2D parameters. So 2D parameters and we have mentioned. Okay, so we have to use the data which I have given here. So by using this data, we have to complete our empennage section in our today's class. Okay, so what we'll do, we'll go to open VSP. So here we have open VSP software. As we know that as soon as we double click, we'll get two windows. One window is our VSP window and one more is the geometrical browser window. Okay, now we are going to design the horizontal stabilizer. As we know, horizontal stabilizer is completely looking like a wing. Okay, so that's why from this geometrical browser we have to select the wing component and we have to add. Okay, so now we have to do alterations for this default wing. Okay, because this is the VSP wing. Okay, with default values. As we know, whichever design we are doing, or else whichever wing, if you are, if you want to create or design in the OpenVSP, you will use the data, right? So that is what I told in previous classes while discussing about a wing component and while designing different type of wing, right? So now what we have to do, we have to use all this data. Okay, and we have to complete our horizontal stabilizer, this component. Okay, see, this default wing is not like that. No, I'll show the top view. It's not like that. What we need according to our requirement, this wing is not like that. Okay, and also the parameters, right? Span for this default wing is 18, chord 2.5, area something else, but for our case clearly have mentioned, so we have to use this data. Okay, so that's why, see, in putting number in the open VSP, it's very easy, but getting that number is very hard. So that's why analytical part is very very important, and geometrical analysis, okay, conceptual sketch what you will do, that is very very important. Okay, once you're done with this 2D sketches or the geometrical parameters, if you done clearly, then just use these values and generate your model in the OpenVSP software. Okay, so now we have the default value. We will use our given data, okay, to complete this horizontal component. Okay, now what I'll do, I'll just use this data span 47.54605 feet. Okay, see here, for main wing span was different for this case. Okay, we can call this also wing, but that is horizontal stabilizer. Okay, so this parameter and the main wing parameter is completely different. Okay, and size also different. So now we will use our parameters. Okay, span 47.54605, that is what I given. I'll suggest all of you, those who are watching, okay, those who are going to watch to complete this project, follow these values. Okay, and later you can create, or you can design, or you can build your own models, okay, in the OpenVSP. Okay, after this sketch, so we'll use the span 47.54, 47.54, 47.54, and I'm not sure, 47.54605, enter. Okay, that is done. It now next what we have, chord 9 feet. No need to disturb this projected span, whatever span you will give. Okay, you will get that default value, so just maintain as it is. No need to disturb that projected span. Okay, 2D view you can calculate, okay, that projected span. Will be not much difference. If you want the default, you can maintain default, otherwise you can calculate and you can mention that value. Okay, it will be just 1 or 0.8 or 9% difference will be there, that's it. Okay, if this one is 47.4 like this we have, then this one will be 47.0908 or 0705 like that will be there. So that's why I'm not disturbing this projected span. Chord I have mentioned how much, 9 feet, right? So we'll use that value 9 feet, enter. Okay, and as soon as we give these two parameters span and chord, we'll get this area and aspect ratio. Okay, automatically, because this area and chord, they are directly proportional to span. Okay, aspect ratio and area is directly proportional to your chord. Okay, which means they are related, these parameters. Okay, span and chord, they are related to area and aspect ratio. If you increase the span, then you can able to see the change in the area and aspect ratio. Similarly, if you disturb your chord, then again you can able to see the change in the area. So that's why if you have any one of this parameter, two parameter, then no need to disturb this two parameter. Okay, so that's why I'll use these two parameters itself. 47.5460, enter. Okay, and this one 9 feet, enter. So whatever area you'll get, just to maintain that area and aspect ratio. Don't need to disturb these two parameters. Okay, next we will jump to section. Okay, so here, yeah, by looking to this views what we have 2D view, you can able to see no need to split any section. Okay, no need to split any section, right? Only one section is enough, so that's why I'll not split any section. Let it be one section itself. Okay, for this one section we can do alterations. Okay, span 23.707. Here I mentioned root chord. How much? 13.5. 13.5. Enter. And pip chord 4.5 feet. Enter. Okay, this is done, right? And sweep angle also I have mentioned 35 degree. Sweep angle instead of 30 we'll change this to 35 and enter. Diagonal angle 8 degree. Diagonal angle 8 degree. Currently diagonal angle is 0. See, if I change the diagonal angle from 0 to 8, then you can able to see the changes. Enter. Right, so this is done, right? Yeah. So now we will jump to aerofoil. Yes, so we have root chord and tip chord. Okay, so here now currently we are here aerofoil section. Currently we are here. Okay, so for that case I mentioned NACA 0020 aerofoil, and for tip chord NACA 0017 aerofoil. So we will add these two aerofoils. Okay, NACA 0020 aerofoil root side and NACA 0017 aerofoil tip side. Okay, so now we are currently root side. Okay, to jump tip side you can just click like this. Root side NACA 0020. 0020 this is no need any camber. Camber is 0. Okay, only thickness to chord ratio 10% is there. We will change this to 20% as per our requirement. Okay, that is done. So NACA 0020 aerofoil has been added. NACA 0020 aerofoil has been added at this road side. Now we will jump to tip side. Okay, tip side default NACA 0010 aerofoil is there. So instead of this, we have to add NACA 0017 aerofoil. Okay, so thickness to chord ratio is 10%. I'll change this to 10 to 17. Enter. 0017 aerofoil has been added at the tip side. Okay, done, right? So everything is done, only these parameters have given. So all this given parameter has been added in this wing, and hence we have done with the horizontal stabilizer part. Okay, top view, front view, left view, so this is our left view. Okay, and top view, this one top view. Okay, this part. Right, now front view. Okay, so we have done with the horizontal stabilizer. Now we will save this part. Okay, First, let me shade this component. And okay, to save this component, the name of this component is wing geometry, so we will just change this to horizontal stabilizer. Okay, horizontal stabilizer. Okay, enter, done. Okay, now we'll go to file. The material is default material only. Okay, later we'll add material. Okay, let it be default material itself. If you want to change the material, you can change like this. So this is what I have shown here. That's it. Okay, there's no any difficult. So I'll just maintain default material. I'll go to file and I'll use save as option. And directly you can save this. Okay, so it's asking you path where you want to save. So just select the path where you want to save. Okay, suppose you want to save here itself, just give file name as a horizontal stabilizer. And just type yes, horizontal stabilizer, accept. Okay, to check that, just you can go to that same path. Here you can able to see it's just .vsp. Just now I saved this file. That is horizontal stabilizer. Okay, now we will go to next component what we have, that is vertical stabilizer. Okay, I'll delete this. Okay, now what we have done for a horizontal stabilizer, same case or same procedure we have to follow for vertical stabilizer. But in this vertical stabilizer you can able to see little bit change we have. Okay, what change is there here? We have to split this wing into two components, first component or first section and second section. Okay, because first section what will split that has been placed here, and the second section we can able to see vertical position, right? So to achieve that we have to split our default wing into two sections. Okay, so now we'll use the parameters. Okay, so here we have vertical stabilizer parameters and top view, left side view and front view. Okay, with respect to these views, parameter also I have mentioned span, chord, area, section. Okay, this wing has been split into two section, first section and second section. This is our first section and this one is our second section. Okay, first section parameter also mentioned and second section parameter also mentioned, and after that aerofoil, which aerofoil has been added. Okay, aerofoil 1, aerofoil 2, aerofoil 3, and this three section. Okay, which means this side and this side. Okay, so three section has been added. Okay, root side, mid side and tip side. So what we'll do now, we'll go to open VSP, we'll add the wing. So this wing is the default wing. For this default wing, now we have to use our parameters. Okay, see, we are designing vertical stabilizer, right? So we don't need the symmetry part, so that's why I'll off just symmetry part. Okay, I'll just use half wing. Okay, now this one, what we have, this wing is the default wing. Okay, or I will call this is our default vertical stabilizer. For this default vertical stabilizer, we have to do changes as per our requirement. So I'll use our requirement values. Span 27 feet. So span 27 feet. We have to type here 27 and enter. Okay, done. So and after that, what we have next? Chord. Okay, 16.20. That value we have to input here. Chord 16.20223. Enter. And no need to do anything for this area and aspect ratio because span and chord is given, no? So automatically we'll get those two parameters, so no need to do any changes to that. Okay, so after this, now what we have to do, we have to come to section. As we know, this vertical stabilizer has been split into two sections, first section and the second section. Okay, so that's why for this complete vertical stabilizer, I'll split now. So here we can use this option and I'll split. So this vertical stabilizer has been split into two section, first section and second section. So I'll just come to first section. Okay, first section, this section. So for this section, I have given the parameters. Okay, first section parameters mentioned. So these parameters will use span 6.5 feet, span 6.5 meter. Okay, and root chord 30.5, 30.5, enter. Tip chord 14.948, 14.94854, enter. So now, okay, later I will tell about this. Let me first complete the given data. So first section I have given on the parameters, right? Now sweep angle I have to mention, no? Sweep angle for this case 69 degree. So 69 degree, enter. Sweep angle is done, and next we have to go for second section because for this first section only these parameters I have mentioned. So next we'll jump to second section. Okay, because first section parameter done, right? So now we'll jump to second section. Okay, this section, which means This is our second section. Okay, now in this case we have the span 20.5 feet, 20.5, enter, and root chord as we know 14.9, 485, root chord 9485, default we got the same, and tip chord I have mentioned 4.411, 4.411, enter. Okay, and sweep angle 36 degree, sweep angle 30, we have the default 30 value, so 30 degree has been changed to 36. Okay, enter. So here we have done with the given parameter, right? Now we will jump to aerofoil. Okay, so currently we are on this section. Okay, and here we have the mid section, and here we have the tip section. Okay, which means root section, mid section, and tip section. So we will come to root section. Root section aerofoil I have given 4 series aerofoil NACA 008, NACA 0015, NACA 0030. Okay, 8%, 15%, and 30% 4 series NACA aerofoils we have to add at root side, mid side, and tip side respectively. Okay, so that we will complete now. Okay, we are on root side. So for that case, the aerofoil is NACA 008. So just we have to change the thickness to chord ratio. NACA 008 done at root side. Now we'll jump to mid side. Okay, that is NACA 0015. Enter. This is done. And last tip side 30% aerofoil. Okay, tip side NACA 0030, enter. So NACA 0030 aerofoil has been added. So here we have done with horizontal stabilizer and vertical stabilizer. So currently we have done with vertical stabilizer. No, just yeah, all parameter has been done. No, so I'll just delete this and I'll shade. Okay, so here we have the top view. Okay, I mean like top view, front view, left view, front view. Okay, and left view, and right iso view. I'll share this component. So here we have default. Okay, you can change this to as per your requirement. So I'll just maintain default value itself. I mean like default material. Okay, right iso. So this component is the vertical stabilizer. This one. Okay, I mean this part, this part. this part is done. Okay, so here in today's class, as per our aim, we have done with horizontal stabilizer and vertical stabilizer. Okay, so in our next class we'll go to next component. So I'll stop here. For this same again we have to go to file, use save as option, and give name as okay. Before this we have to change here. Okay, just type VH vertical stabilizer, VS vertical stabilizer, enter. Go to file, save as, and type file name vertical stabilizer, accept. So this file has been saved. Okay, vertical stabilizer, VS vertical stabilizer. Okay, so we have done with our horizontal stabilizer and vertical stabilizer. Thank you to all for listening the class. Viewers, just follow all these components. I mean, like all these values which I have mentioned. Okay, these values are very important. Okay, once you have this value, then only you can able to generate this model. Okay, that may be your horizontal stabilizer or vertical stabilizer or any component. Okay, any wing parts or any aircraft parts. So that's why the analytical part is very important. I mean, like geometrical part or sketching part or conceptual sketching part. Okay, so that is like a basement. Okay, once your basement is done, then easily you can create and design your model in the open VSP. Okay, so I'll stop here. We'll continue in the next class. Thank you.
Okay, thank you, sir.
Okay, thank you, sir.